Hey guys, welcome back. I hope you're having a great day. Today we're going to be going over lesson 5-6 in geometry. Now, we're just kind of going to build on 5-5, and instead of doing inequalities in one triangle, we're going to apply that knowledge to what we know about two triangles. So this yields some interesting theorems called the hinge theorem and the converse of the hinge theorem, which is basically theorems about inequalities in two triangles. So, the hinge theorem states that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is across from the larger included angle. That sounds really complicated. I'm going to show you what all that means. Here, in this triangle setup, we have two triangles. We have ABD and triangle BDC. Now, we know that BD is congruent to itself because of the reflexive property, and we're given that BD kind of bisects, it kind of goes through the midpoint of AC, so we know that AD is congruent to DC. So there we go. We've met that condition of two sides of each triangle have to be congruent to each other. We have BD is congruent to itself, and we have AD is congruent to DC. Alright, that's great. Now, what does that mean? The included angle is basically the angle in between the two sides we're mentioning. So we're mentioning BD and AD. So this angle right here is going to be the included angle. The same thing holds for this angle. So, if we know that angle ADB, so this one right here, is smaller than angle BDC, we know that the opposite side, AB, is going to be smaller than this opposite side, BC. And that's because we have a larger angle here, which is going to correspond to a larger opposite side. We have a smaller angle here, which is going to correspond to a smaller opposite side. The same holds true with the sides, right? So let's say we're given these two partially congruent triangles, and we're given that AB is smaller than BC. We know that the opposite angle ADB, is going to be smaller than the larger side's opposite angle BDC. So let's kind of go ahead and transverse over to this this example here, and we're given that this side is 10 and this side is 11. We're going to go ahead and look over at this triangle. We're given that this side is 10 and this side is 11. So that meets the requirements of two sides of two triangles being congruent to each other. Now the included angle, the 30 and the 90, are different. So that means that we're going to use the hinge theorem. I think, maybe the converse. So we know that 30 is less than 90. So we know that AC, right here, is simply going to be smaller than XZ. So we could do the same for sides. So let's take, for instance, let's say this side were 5 and this side was 9. We would know that the opposite angle to AC, which is obviously B, would be smaller than the opposite angle of XZ, which is Y, and that's 90. So this is going to hold true either way we decide to do it, and it's going to hold true throughout all the examples we do in the homework. So I hope this helped, and I hope this is kind of a short video. I know that these past two have been a bit longer, but I hope it helped, and I hope you let me know if I did well. Thanks.